We have 2019 question 3, no calculator, and the topic of graph of a derivative. Now, whether this problem needs to do the following or not, I want to tell you, make sure you're aware of a technique or remind you of this technique that often saves you in problems like this. This is the graph of f. Pretty much every time these show up, that graph is the derivative of somebody you're asked questions about. So I always immediately, when I see these problems, take the name of the graph and make a number line chart for it and put on that number line the endpoints. And then anywhere that that function is equal to 0 or undefined. It is equal to 0 at x equals -1. It is equal to 0 here, which if it's on this line, that's got to be 1/2. And it's equal to 0 at the other endpoint. Then where is it positive, negative? It's above the x-axis, below the x-axis, above the x-axis. I will then make a chart for the derivative of the graph that is given. And again, put the endpoints. And now I'm looking at, is it heading up or down? It is heading down until x equals 0. Then it is heading up until x equals 2. And then it is heading down the rest of the way. Down, up, down. Those two charts in particular are going to help you answer a lot of questions. Any question about increasing, decreasing, relative maximum, minimum, absolute maximum, minimum, point of inflection, concave up, concave down, any of those questions, start by literally covering up the graph with your hand so you can't see it and so that you only see these charts, or it will mess you up. Because they will ask you like, hold on, let me see where they are talking about the function. You're integrating, come on. You're being asked to pen. Sorry, it's my annoyance with my pen. We are integrating the graph of that function and dealing with questions about it. If you're looking at the integral function and they ask you a relative minimum, you're going to be tempted to give them this. It's way too tempting. But if you know that you're looking at, say they tell you that the derivative of g is the f function, and they ask you about a relative minimum, you look along here and you see changing from negative to positive, 1/2 is where it has a relative minimum. So I want to point out to you how useful these charts are. For free response problems, sometimes the charts barely answer anything, sometimes they answer a ton. But I would advise those charts to chart out what you're working with. Now, in part A, from -6 to 5, it is telling you the value of the integral, and it wants you to find the value of the integral from -6 to 2. What I like to do personally is make a number line and write down all those numbers. I've got a -6, I've got a 5, I've got a -2. This helps me to orient what is what with these integrals. When I'm integrating from -6 to 5, I am going over that interval. When I integrate from -6 to 2, that's this one, and it is in this direction specifically. I want to find the value of this one. I'm going to find the value of that. if I also find the value of the integral from negative 2 to 5. So basically, I'm looking at this to see what intervals, who adds to what, make what, who adds to make what, all that. So with the given information, I only need to find from negative 2 to positive 5. I need to figure out what that integral is going to give me, and then I'm going to subtract that from the number 7. So it's going to be 7 minus, and I'm going to put a big giant parentheses, and now I'm going to focus on the integral from negative 2 to 5. You want to save yourself some time when you notice things like this. Those are equal areas above and below the x-axis. Don't bother counting. Ditto. Don't bother counting. So now I'm going to start off right here, and I can see that I have nothing more to cancel with. Here I have, you can find your area however you find it. I've got one square that is a 1 by 1. I have a 1 by 2 triangle whose area is also going to be 1. Then I have this section, which I was told is a quarter of a circle. So if that's a quarter of a circle, the radius is, that looks like 3 units to me, 3 units. And I'm going to use the fact that I know the area of a circle. It's a quarter. Oh, wait. I'm subtracting the circle. I need to be careful here. I'm going to take the area of this square. The area of that square is 9. And then I'm going to subtract from that the area of the circle. The area of the circle is 1/4 of a circle pi r squared. And again, that is going to subtract from 9. And then I have these two over here as well. So 11 minus the 1/4 pi times 9. And you know what? It's free response. Leave it. Let it be. Okay, moving on. Part B. We need to evaluate this integral. Now, what I'm going to do is I'm going to rewrite that over here. Integral from 3 to 5 to f prime plus 4. As I begin to work through it, I want to separate what I can separate. I can separate the addition and I can also take the multiplication of 2 and pull it outside the integral. For this integral, it's basically just creating a rectangle with a height of 4 and a width from 3 to 5, so a width of 2. That's going to come out as 8 for area. Then I need to focus on what is this. And then I want to remember, hey, I've got information about f. And if I'm integrating f prime, then that is f, plug in the 5, minus plug in the 3. But don't forget that that needs to be multiplied by 2. And so now I'm going back up to the graph, and I am going to find my function's f value at 3 and 5. Now I can see that f of 5 is 0. To find 3, though, I'm going to have to create an equation of that circle. What? Oh my goodness. See, I was about to do something the really hard way, and you guys saw the Easter egg. I call them Easter eggs because you think you have to do more, and then all of a sudden you're like, wait a minute, they gave it to me. It's right there. So thank you. And all I have to do now is just bring that together. So I have 2 times my f of 5. No, my f of 5 is 3. Hold on. That's the center. My f of 5 is 0 minus my f of 3 is 3 minus root 5. So I've got 2 times, I'm going to reverse the subtraction, and then plus 8. And that would be the evaluation for letter B. Now, C moves into play. C wants the absolute maximum value of G, where G is representing the integral of that graph from -2 to x. And this is where I want to turn to my chart, because I want to recognize, and I need to say in my free response, that the derivative of G is f of x, fundamental theorem of calculus. And then I'm going to go back over to my charts that I made, and I'm going to write down that f is equal to g prime, and that the f prime is then g double prime. I may not need that, but I have it in case I do. I want the absolute maximum value of g, so I want to look at g first goes up, and then down, and then up. The possibilities for absolute maximum are the relative maximum, which is x equals -1, and the right endpoint, x equals 5. I know that based on this information, and I need to make sure that I justify. Now, let's see. I am going to find the actual value, so I might as well go through the process of finding the actual value. If you want to stay on the safe side, you can make a t-chart for my input x, and I'm trying to maximize g of x values. If I check x at every endpoint and every critical number between an endpoint, and I find the g of x values that go with it, that's staying on the safe side. However, I have seen the AP test often only check the points that have the potential for absolute maximum, even though technically you are supposed to be checking endpoints and critical numbers between endpoints. They allow you to use the positive negativeness of slope to know who to not worry about. But you need to then express that you know that. So if you don't, if you check only -1 and 5, you need to make sure that you explain to them that you know that the derivative of g is positive, and then state what intervals. The derivative of g is negative, and then state the intervals. You would need to do that. But maybe it's actually easier just to write all the y values. So -2 to x. So when x is -2, I'm just looking at the integral from -2 to -2, and that's 0. When x is equal to 1, I am looking at from -2 to 1. And do you remember with that was actually, and by the way, if you're a little bit confused about which region do I need to look at area, draw vertical lines from the function to the x-axis. And that will allow you to see which regions you're actually looking at area. And if you remember, this came out to adding nothing because we've got positive, negative, same area, positive, negative, same area. I am adding nothing to the 0 that I already had. Actually, one second, because now I'm starting to why am I oh, silly. I went to 1 and I was supposed to go to -1. That's why I am confused. That's where I'm at after dealing with that stupid science test and trying to figure out, what do I do with you? I don't know. You don't know your state student ID number? Okay. You don't either? Okay. You don't either? Okay. I'm sorry. I'm complaining about earlier today. Deep breath. So I am just looking at that area. That's a 1 by 1 triangle. That area is 1/2. Then my next critical number is when x is positive 1/2. And at that point, I will have taken away that addition of 1/2 and brought in the area of this little tiny triangle here. It's a 1 by 1/2. The area of that triangle is 1/4. And then I don't need to do any extra work for 5 because I found it already. This right here is the answer to the integral from -2 to 5. So that is 11 minus 9 pi over 4. Now I've got to figure out which one is going to be larger. And if I do a comparison, right here when I'm at x equals 1/2, I'm only subtracting away, oh my goodness, less than 1 unit, and I'm adding a whole lot more. So this is definitely larger. Do you see what I'm saying with looking at it by view of how much area is in there? I can see that this is the winner, but in order to justify, you need to make sure that you explain that you say, these are my 2G values at my potential absolute maximums. And then say the absolute maximum is this one as your final answer for that. Yeah.
Did you just say that it has like the greatest value of all the critical values?
No, you have to use calculus. You have to explain it through calculus. What you're describing, you could say the integral from -1 to 5 is positive. So that shows that you gain more than you lose. That is a calculus explanation of that, and that's acceptable. It's just they have to have a calculus explanation. I think that gets the point across. Okay. And so that is part C. Part D, I'll bet that's a L'Hopital, but let's see. If I plug in 1, if this is L'Hopital, I'm going to have to do the limits separately anyway. So limit as x approaches 1 of 10 to the x minus 3 times f prime of x. What does that equal to? Well, I know 10 to the 1 is 10 minus 3 times. What is f prime at x equals 1? At x equals 1, f prime is the slope of this line. The slope of that line is 2. So this is not a L'Hopital. What? Okay, guess it's not. Then let's look at the denominator. I'm just going to write down 10 minus 3 times 2. Okay, so what is f of 1? Actual y value at 1 is 1. And then arctangent 1. So keep in mind that input-output swap when you're dealing with inverses. So it's asking, what is the angle whose tangent gives me an answer of 1? And what angle does that? Pi over 4. And that would be an answer to that limit. You can simplify or not simplify, and you've got it right there.